Now we are going to start with the Avgadro law. This law actually gives us the relationship between volume and moles of the gas, keeping temperature and pressure constant. So this is a relationship between volume and moles. So what does it states actually? It states that suppose first I will read the statement. It is that the equal volume of gases, that means if the gas volume is volume A, or you can say, if I say gas A and gas B, same volume VV, right, same condition of temperature and pressure, they will contain same number of molecules. So suppose if I have a gas whose volume is V, A gas volume is A, for B gas volume is again V. So they said that they contain the same number of molecules also, provided that the temperature and pressure should remain the same. And likewise we can have the opposite thing also, that if the number of molecules are same, they will possess the same volume also, keeping the temperature and pressure constant. Suppose let us take the number of molecules in terms of mole. Suppose if I have gas A and gas B, gas A has X moles and similarly the gas B have the same X moles. So they will actually occupy the same volume, provided temperature and pressure should remain constant. So this just tells us that when we have equal volume of gases, they will possess same number of molecules, or you can say that if we have same number of moles, they are going to, of different gases, they are going to occupy the same volume. It doesn't matter whether it is O2 or N2 or H2 gas, what matter is the volume and the moles. We need to relate them. So that means it shows that volume is directly proportional to number of moles of gas. Now we have seen that when we talk about moles, moles corresponds to this much molecules, 6.022 into 10 raised to power 23, that is the Avgadro number. So if I say that A gas has volume V, B gas again have same volume, so how many molecules they will contain actually? They will contain the molecules, the same number of molecules. Likewise, if we have X mole, that means if we have this much molecules of A, this much molecules of B, they are going to occupy the same volume, irrespective of the nature, that whether it is O2, N2, H2, whatever gas it is. We are just concerned with the same number of moles, and they will, the same number of moles at same condition of temperature and pressure will possess the same volume. This is what is there. Now we have seen that at STP condition, that is the standard condition of temperature and pressure, that is 0 degrees Celsius in 1 bar, or we can write 273.15 Kelvin or 10⁻⁶ Pascal. The volume for the ideal gas is calculated to be 22.71 liter per mole. That means when we have when we see it for 1 mole, they occupy the same volume, that is the 22.71 liter per mole. Now I am going to explain it to you with a logical experiment. Let us take 3 Coke bottles, A, B and C. This is my Coke bottles filled with Coke, they are not empty. And I have Mentos. You know that what is Mentos? It is a mouth freshener type, right? You can say a round tablet in a form of white color, right? So what we have is, we have balloon A, B and C. Now what I am going to do it, I am going to add 2 Mentos here, I am going to add 5 Mentos in this bottle, and I am going to add 8 Mentos in this bottle. Now after that I am going to fix a balloon on them. So what I will see that, you know that they already contain a gas, and when the Mentos and Coke will react, they will somehow produce more gas. So we see that the bottle which has more number of Mentos, they will react more with each other, more gas will be formed and more gas will be collected in this balloon. So somewhat this balloon is going to be bigger in size as compared to this one, and smallest will be the one which contain the less number of Mentos. So this actually shows that when you have more number of moles, so that means there is more gas, that means there is more volume, that is why the balloons get more bigger in size. So this is what is the Avgadro law.